Hello everyone. I'm going to kind of talk through in LT5B. And so this is still under our LT5. So that was the mathematical and computational reasoning target. So that was doing word problems with Unit 1. And LT5B is proportional reasoning. And I think the best way to illustrate what proportional reasoning is actually through an example. So I'm going to write down an example and kind of talk through how you decide these things, how you go through this problem solving process. So a crane is lowering a large beam to the ground. The large beam suddenly starts to move much faster than before. And you realize acceleration has doubled. Okay, and the big question mark with proportional reasoning is always it's always comparing two different situations that are kind of similar, but there's something different about them as well. And we want to figure out what all of those different things are and what the same, what are the same things. So in all our proportional reasoning problems, we are going to use our Newton's second law equation. So to remind you, that is this equation. So there are three variables, and if one of those variables changes, then at least one of those other variables has to change. So basically, two of these variables are going to change. The other one will usually remain constant. So, first question to ask ourselves is, what is constant? So out of these three variables, F net, mass, or acceleration, we want to know what is constant and what is changing other than A, because we know acceleration has doubled from the prompt. So read that prompt. What is changing and what is constant? It's the same beam. It's the same beam. And so what that means is that the mass is going to remain constant. Now what else is changing? F net. And that makes sense because our F net causes acceleration. And so if acceleration is changing, most likely that net force has maybe caused it to change. Okay, so to do proportional reasoning, what we do is, instead of plugging in numbers, because we don't actually know what the mass of the beam is, we don't actually know what the acceleration was originally, all we know is that acceleration has doubled. And we also know that mass has remained constant. So it's not changing. It's changing by a factor of 1. If my first mass was 20 kilograms of a beam, then in the second situation, when it starts to move a lot faster, that beam mass is still going to be 20 kilograms. So I haven't changed that mass at all. We plug in ones for things that are constant. And then we try to figure out what goes in front of that F net to make our equation true. So essentially what we're doing is we are trying to figure out what did we multiply this side of our equation by because we changed certain things. And then, so in this case it would be 2. And then on this side, it must also be 2 since we want to multiply both sides by the same quantity. And so our F net does change by a factor of 2. So I often like to write it like this. So I just pull the factors and I get that my question mark is equal to 2, which means it's 2 times my F net. Then we are going to add in applying the factor of change. And applying the factor of change might be a little bit confusing. But for example, we might give you if the original F net was 600 newtons, and the beam has a mass of 500 kilograms, what is the new F net? Well, we could figure out what our old acceleration was by doing 600 divided by 500 kilograms. F net divided by m gives us a. But that's a lot of work, and then we'd have to double the acceleration and multiply that by the mass to get this new F net. Well, the whole purpose of proportional reasoning is that this process all of a sudden became super easy. Because all we have to do is take the old F net and multiply it by 2, just like this equation says. So the new F net is just going to be 600 times 2. So this is the process of proportional reasoning. There are a couple different methods, and we'll just use the same example and talk through the process of each one. So method 1, because you always have to write your equation still, I like this first method because it has my equation already written in. My mass is constant, so I plug in 1. And reminder, this is the same example we just did. Acceleration was doubled because the problem told me so. And then I'm looking for this F net variable. And I get question mark is equal to 2, so that means 2 times net force. Method 2 is that you write your equation, and you also don't have to show all of these steps. You can just go from here to here if you can. So you only have to show this much work. Method number 2 would be to write your equation and then plug in the factors. So since mass is remaining constant, we would plug in 1. Since acceleration is doubling, we would plug in 2, and then we would solve for F net like that. And so F net would be equal to 2. So then we would say 2 times net force. We get the same answer, it's just that our method is slightly different. Okay, now the last thing I want to talk about is the success criteria. These are things that you need every single time. And our success criteria are equation. So that's that equation in variable form. Or writing it like this also counts. identifying factor of change. So that's kind of the setup of the problem, identifying that things that are constant have a factor of change of 1, they don't change. The acceleration has doubled. Then determine factor of change. So that was the 2 times F net. If I had said 1/2, for example, for F net, that would be incorrect. And then apply the factor of change. And that is it. You have lots of practice to do, and the keys will be posted tomorrow. All right, let me know if you have any questions.